grade, we are open to page number 33, lesson 6. We're going to look at adding whole numbers. So lesson number 6, we're going to be looking at adding whole numbers. First of all, I have a question. What is a whole number? 5th grade. Do you remember what we always think about when we think about whole numbers? Rebecca? Yeah. It starts with 0 and includes every counting number. Like 1, 2, 3, 4, 5. But we always have to remember that good old yummy donut, right? With the big old hole in the middle. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way through infinity. And now all we're going to do is learn how to add multiple whole numbers together. Like this, 6, 3, I'll do an easy one. 6, 3, 4, 7. And they're going to be asking you to add this. Some of us, even in your head right now, you're starting with 6 and you're counting on your fingers, 6, 7, 8, 9, 10, 11. That's not what we want to do. I'm going to show you a shorter way. Not saying that that's wrong. I'm just going to show you an example that's going to make it easier. I want to partner up digits, counting numbers, that equal 10 when I add them together. So if I take 6 and 4 and I add them together, that equals 10. And 3 and 7, what does that equal? 10. So then I can just add 10 plus 10 equals 20. So instead of going 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, counting by ones the whole way. Are you okay? Ouch. All right. Oh, I don't like needles. Okay. All right. So, Kaylin, so when we add the digits together, we find groups of 10, and then we just add the leftovers. In this case, we don't have any leftovers, do we? So we took 6, 3, and 7, and 4, added them together, found 10 plus 10 equals 20. It's just shorter. Let's take a look at another one. What about this one? Do you see any pairs of 10 that make 10 when they add them together? Adam? Yeah. 5 plus 5 equals 10. Does 6 plus 2 equal 10? No. So I can add those just leftovers. 6 plus 2 is? So I can add that, and my answer is 18. All right, example number 1 on page number 34. We're looking at page 34. It says, what is the sum of 7, 4, 3, and 6? 7, 4, 3, and 6. What does the word... Oh boy, that's bad. What does the word sum mean? Kaylin? The answer to an addition problem is correct. So I need to add 4, 7, 3, and 6 together to find the sum. Because this is important. Because they're going to ask you this. Find the sum. Find the difference. Find the quotient. And find the product. And they'll give you 7 and 4. And you have to know it's all different. With sum, I add it together. 7 plus 4 equals 11. Difference of 7 and 4, what am I doing? Subtracting. 7 minus 4 is? Quotient. What am I doing? Adam? Dividing. And 7 divided by 4 equals? 1 and 3/4, or 1 remainder 3. And product equals? Times, which is? Christopher? 28. So we have to know what they're asking. And so it's important that right now we're starting at the foundation. It might be super easy, but you have to remember what the word sum means. Sum means add. Difference means multiply. Quotient means to divide. And product means to multiply. All we care about today is sum. Sum means add. So back here, 7, 4, 3, and 6. Do you see any groups of 10? Kaylin? 7 and 3 equals 10. Does anybody else see any others? Grace? 4 and 6 grouped together equal 10. Just like we started with. And 10 plus 10 equals? So the sum equals 20. Yeah. Look at the example number 2 on page 34. It says 4 one-digit whole numbers are added. Is the sum more than 40, more or less than 40, and how do you know? So, 4 one-digit numbers. 1, 2, 3, 4. Is the answer going to be greater than or less than 40? Think about it. There's no question mark. You forgot the question already? I have 4 one-digit numbers. I'm going to add them together. Is the answer, the sum, going to be greater than or less than 40, and how do you know? Brianne, what do you think? Touche. But I think that we do know, and your math book thinks you do know. Not the answer, but now, what is the greatest one-digit number? 9. Let's place a 9 in all of these boxes. What's 9 plus 9? What's 18 plus 9? And what's 27 plus 9? 36. Max sum I can get, Kaylin, is 36. The only way that these 4 numbers would equal 40 is if all of them were 10. But it doesn't say I can use 2-digit number. It says I can only use 1-digit numbers. So we know that it is less than 40 because the greatest 1-digit number is 9. And when I add it all together, I get 36. Kaylin. Nine times 4. Yes, that's because multiplication is repeated addition. Repeated addition. So 9 plus 9 plus 9 plus 9 plus 9 plus 9 is 9 times 5. Yeah. Mm-hmm. Right. You use multiplication? Well, that's good. All right. Do you guys remember what this is called? Or this? Not addition. This is called the commutative property or the identity property of addition. I want you to picture that this 0 is close. This is the symbol for a fingerprint. The new iPhone 6 is just being launched today or yesterday, and you can pre-order it. And they have a identity pay. They have called Apple Pay, where you can take your phone to any bank and you take your credit card or your debit card or whatever, and you have it on there, and you put your thumbprint on the finger pad. Like right now, I can already put it on there, and then it will like turn up or it'll open up. But they have an app that you can pay, and you just put your fingerprint on and it'll pay. But what happens if Patrick steals my phone and he tries paying like that? Will it work? It won't work because he is not me. This fingerprint is my identity. It's who I am. And whenever you take a number and you add it to 0, it's showing the identity of the number. 2. When I take 999 and I add 0, it's saying, hey, who is this 999? This number is 999. So we call this the identity property of addition. Identity property of addition. Kaylin. In arithmetic, we add, we subtract, we multiply, we divide. Those are also called algorithms. An algorithm is a process on how we do a certain problem. They help us solve them. So, I want you to take a look at example 3, and we're going to figure out an algorithm. It says Jamal had $462. And Maria paid Jamal $58 in rent. It is cheap. It says, then, how much money did Jamal have? So question for you. Which algorithm are we going to use? I want you to tell your partner right next to you. They're groups of 2. And why? Have the other person tell you why. Okay, why? Why, Rebecca? What are we doing first and foremost? Why are we adding? Brian? Yeah, Jamal had some money, and then he got some more. This is a some more problem. And then some plus some more equals the total. So, 8 plus 2, carry my 1. 6 plus 5 is 11, plus the carried 1 equals, carry the 1, 4 plus 1 is, so the answer, Jamal had how much money? $520, correct. Right, can't forget the label. All right, look at your lesson practice on page 36. A, B, C, D, E, F, G, H, I, J, K, L, M, N. It is. So even look at letter A. It says the directions say to find each sum. When adding, look for combinations of numbers that add to 10. So we have letter A. They say 8 plus 6 plus 2. That's easy. We can just take it, Kaylin. If we can go 8, 6, 2, add it together. Do I have a combination of 10? Brian? 8 and 2 is 10, plus my leftovers. 10 plus 6 is 16. Done with A. So A, B, C, D, F, G, H are just like that. Letter I is a multiple choice problem. Where they ask the sum of 5 one-digit numbers is certain to be. Think about what the greatest one-digit number could be. It can't be 10. And then you'll find your answer. Any questions on lesson number 6? Lesson number 6 for next time.